So let's play with HBase and actually fiddle around with it and see what we can do. So what are we going to try to do here? Well, what I'm going to do is build up a HBase table for movie ratings grouped by user. And this turns out to be a pretty good example of the power of HBase and how it can deal with very sparse data. So whenever you have a situation like this, HBase is probably a pretty good choice. Now the power here of HBase is that it is fundamentally row-oriented. So for a given user ID, what we want to do is be able to look up very quickly the movies that user rated. Now remember that the actual rating data is provided to us one line at a time for each individual rating of a user for a given movie. And what we're going to do is write a little Python script that populates this HBase table given that information and constructs a table that looks more like this. So let's imagine that we want to build a service that can very quickly give us back all the ratings for a given user ID. Now, if that's our use case, what we want to get back is a structure like this, where we can say, okay, for a given user ID, give me back all of the ratings for that user ID. So each individual column in the column family for rating will represent a rating for an individual movie. So the schema here is the row ID has a unique key of user ID, and each user ID has a rating column family. And this rating column family can consist of ratings of any number of individual movies. So rating :50, the column family name rating, :50 is the actual column name. Together this consists of a unique column identifier. Says that this user ID's rating for movie ID 50 was 1 star. This user's rating for movie ID 33 was 5 stars. This user's rating for movie ID 223 was 5 stars, and so on and so forth. So that's what we're going to build up in this example. And then we'll do a couple of queries just to make sure that we can actually get our data back when we're done. And remember, this is the whole point of doing this is to have a very scalable and very fast way of querying data that fits this form. So if I know that my service is going to need data in the form of give me all the movie ratings for a given user, this is exactly what I would build to do it. So let's go do it. How are we going to do it? Well, to make it a little bit more interesting, we're actually going to run a REST service on top of HBase. So remember what's going on here. HBase itself resides on top of the HDFS file system where it stores the actual data. And now we're going to run a REST service on top of HBase. That's just a service that you can query through HTTP requests. And we're going to write a client that actually queries that service to store and retrieve data through the REST service. So all of this bottom part, the REST service, the HBase instance, and HDFS are all going to be running on my little virtual machine as part of my Hadoop cluster. Go back there. But the Python client, I'm actually going to be running on my desktop itself. So, from a logical standpoint, that's going to be a completely different system. And you can imagine that I could have many, many Python clients on many, many web servers or even front-end web systems that talk to this REST service that's living on my cluster that then communicates with HBase and then finally to HDFS. And remember again, every one of these boxes may be consisting of many, many computers, an entire cluster in the real world. Okay, so I could have many different REST service hosts sitting on top of HBase, which itself might have many different region servers and many different master servers, and that in turn is sitting on top of HDFS, which of course is storing its data across an entire cluster of computers as well. And in some cases, these clusters may be sharing computers amongst each other. So, ideally, my HBase region servers will be running on the very same servers that are storing the data on HDFS, right? That way I can get some data locality and try to avoid doing network hops whenever I can. But conceptually, this is what we're going to build. So let's go do it. All right, let's get to work. Now, this is going to be a little bit more of a complicated example. You're welcome to follow along, but you're going to need some sort of a Python environment to actually do this activity on your own. So you might just want to watch unless you already have a Python development environment set up running on your PC, on your desktop. That's fine. You can learn a lot just by watching. But if you do have a Python environment and you want to use it, feel free to follow along. I'll put the script in the resources for this lecture so you can actually download that and mess around with it if you want to. So first thing we have to do is get HBase running. We can't actually run a script or a service against HBase if there is no HBase. So first things first, let's actually click on my sandbox, which I already started, and you can see that's running here already. I'm going to have to open up a port so that my Python script can actually talk to the REST service on top of HBase successfully. So to do that, I'm going to right-click on that and say Settings. And from there, I can click on Network, open up the Advanced tab, click on Port Forwarding, And I think I've already set this up, but what I want to do is open up port 8000 for the purposes of my service here. Yeah, there it is already. So I already set up an HBase REST port forwarding here that maps port 8000 on the local host 127.0.0.1 to the guest port 8000. So this means that I'm going to be able to communicate through my virtual box here on port 8000 to my REST service. And if you are following along, you can just click on the plus button here and actually add that in yourself. Again, you're just mapping port 8000 to guest port 8000 on 127.0.0.1. So with that out of the way, we can now start up HBase itself, and I'm going to do that through Ambari. So let's go ahead and open up the Ambari dashboard here. Actually, I'm going to log in as admin. That way I can be sure I have the necessary permissions to actually start and stop services. So let's go to the HBase service. And if we go to service actions, one of them should be to start it. So let's go ahead and kick it off. And in a few seconds, that should complete. In fact, it should take about 16 seconds based on past experience here. And HBase is now running on my virtual box. So next thing I need to do is actually launch a REST server sitting on top of HBase so I can communicate with it from the outside world. So let's log in to my virtual machine here, and I will log in as Maria_dev. And again, since I'm going to be starting services and stuff like that, I'm going to actually super user up to root. Again, on a real cluster, you'd have a more appropriate account setup for this sort of a thing. But what I'm going to do is type in user/http/current/hbase master/bin/hbase daemon.sh start REST on port 8000, and there's also an info port that you can actually log into to see what's going on with HBase on, and I can run that on 8001. I didn't actually open up that port, so I can't actually access it, but you do need that parameter anyway. So let's do that to kick off the REST server that is sitting on top of HBase. So at this point, we have an HBase instance running on top of our HDFS instance, and a REST server sitting on top of that can vend, get, and put requests and whatever else to whatever service we have sitting outside of our little HBase cluster. So let's do that. We have our back end running at this point, if you will, and let's work on the front end. So I'm using a Python environment called Canopy. There are many others out there that you might choose to use instead. All works the same way. What I'm going to do is use a package called Starbase, which is basically the REST client for HBase with a Python wrapper on top of it. So if you are following along, you will need to install the Starbase package into Python first. That might be through the pip command, where you can say pip install Starbase, but depends on what kind of a IDE you're using. Okay. Once you have Starbase installed on your system, though, we can use it. And all we're going to do is import the connection object from it. And we're going to create a connection object using our IP address for the local host, 127.0.0.1, and on port 8000, which is both the port that we opened up to our virtual box and also the port that we told the REST server to actually operate on. So with this, we have a connection to the REST server sitting on top of HBase. Now it gets fun. So I'm going to say, go create a table named ratings. So this is where we're going to actually create that schema that we saw earlier in the lecture. Now, if it already exists, I'm going to drop it because I'm going to replace it with a new one. And I will then, within the ratings table, create a ratings column family called rating. Okay, so creates a column family on a given table. Okay. So next thing I want to do is actually open up the ML100K data set, and I actually saved it on my system to this path. Again, if you're following along, replace that path with wherever you saved the u.data file. I'm going to open it as read-only. And now we're actually going to import it into HBase. So the Starbase package has a batch interface. So instead of actually trying to add one row at a time, that would be pretty inefficient. I can actually batch things up and do it all at once, which is a lot faster. So the first thing I'm going to do is create a batch object from my ratings table. And then I will keep updating that batch with new rows, where the row ID is given by the user ID I extract from the u.data file. And I will say the rating column family is going to populate itself with a rating column of the movie ID with a given rating value. So this ends up with a row that has a unique key of the user ID. Under the rating column family, it will construct individual columns for each unique movie ID. So the column will be given by rating : movie ID, and the actual value in each cell is the rating itself. So when we're done, we close the ratings file because we're done reading it. We commit the batch through the service so it actually gets written into HBase. And at that point, we can start querying our data back. So now we can simulate just being a client that's trying to read this information back. Say I want to get back all the movie ratings for user ID 1. I can just say ratings.fetch1. That will give me back a big data structure in Python that I could then do interesting things with, like construct a web page that's actually pretty and human readable. And I'll do it again for user ID 33. That's a bug there. My print statement didn't match up with the code. That's not good. So let's run it and see if it works. I'm going to open up the output window here and just hit play. And if we're lucky, all will go well. So it's opening up that connection to HBase. Got that far. It has already read it all in, and it's now writing it all through the REST service to HBase itself. Now it's reading the data back. Takes a little bit of time to synchronize, and there it is. So that's pretty awesome. That was pretty quick, huh? So we actually read in 100,000 movie ratings right there, populated our HBase database with it, and very quickly read back the actual list of movie ratings for a couple of users. So just to break this down, what we're getting back here from the fetch call on user ID 33 is a structure that looks like this. So our rating column family consists of these columns, where the movie ID 751 was rated 4 stars, 880 was rated 3 stars, 339 was rated 3 stars, and so on and so forth. So this consists of the complete set of movie ratings seen for user ID 33. And this is powerful, right? Because those ratings were just interspersed throughout the entire data file that we input originally. So this gives us a very fast way of retrieving the entire list of movie ratings for a given user ID. And you can imagine real-world applications for that, right? Maybe you want to display back to the user all the stuff that they've already rated before. Maybe you want to use that list of movies to filter out some recommendations or something like that. So, that's a really concrete real-world example that has real applications. And remember, too, that we might have many, many of these scripts running at once. So we could be hammering that REST server with rating requests from a bunch of different front ends. And, with a sufficiently large cluster on the back end, it would just handle it. So there you have it. HBase in action. Very cool stuff. Let's shut things down now that we're done with it, just to clean up our mess. So we're going to type user HTTP current HBase master bin HBase daemon.sh stop REST, and that should shut down our HBase REST interface. Okay, now we're going to keep the HBase service itself running because we're going to use it again in our next exercise.